Imagine a single raindrop catching a sunbeam on the edge of a leaf. Notice how the light narrows, becomes a thin thread, and then spills into color: red, orange, gold, green, blue, like silk unspooling. Let your breathing slow with that image. Breathe in gently, breathe out as you watch the tiny arc. This is the promise of what we'll wander through together, the most relaxing facts about rainbows and light, spoken softly, held close to the way a raindrop holds a whole miniature sky. Picture that drop again. See it as a tiny glass world. When a ray of sunlight meets its curved surface, the light changes direction. It bends, a little like fingers guiding a ribbon through your hands. Inside the drop, the beam splits into colors, because each color bends differently. Red sings a wider, softer curve. Blue takes a tighter turn. The drop nudges the light into a small, perfectly ordered fan, and for you, watching from a few steps away, those rays line up along a curved path. From your vantage point, the many drops around you arrange those rays into a faint arc, an opening of color that seems to hang just beyond reach. If you feel drawn in by this quiet explanation, and you think others might enjoy this slow kind of curiosity, a like or a subscribe helps this calm corner find more listeners, only if you'd like. The first thing to hold in your mind is that a rainbow is personal. It only appears for you when the geometry between the sun, the rain, and your eyes is right. Move a little to the left, and the arch seems to slide with you. Step forward, and it bows away. That shifting, private rainbow forms because every droplet sends color in all directions, but only the drops lying on a particular cone of angles return specific colors to your eyes. This cone is why rainbows are always opposite the sun, and why they arc level with your horizon. Think of it as a soft promise. Wherever you stand, the light arranges itself to meet you. Inside that rain circle are two familiar companions, the primary bow, and, if the rain is generous, a faint secondary bow above it. The primary is the brighter, the one you can trace with your finger in a daydream. Its colors run red on the outer edge and violet inside. The secondary bow appears higher and paler, its colors reversed, violet on the outer edge and red on the inner. Its gentler voice comes from light that has taken an extra bounce within the drops, losing some intensity and swapping its order. If you look closely near the bright primary, you might notice delicate, narrow fringes, supernumerary bands, soft stripes that appear like the echo of the main colors. Those come from interference, a gentle wave playing between colors, and their presence is a quiet reminder that light behaves both as a beam and as a ripple. A prism and a prism and a peat is the same lesson as that rain bead. Hold a thin wedge of glass, an old-fashioned crystal prism, up to the sun and watch it spill a tiny spectrum across a tabletop.
The effect is the same. Different wavelengths bend different amounts. Red, which bends least, slides gently. Blue bends more, leaning inward. The angle between the incoming beam and the spray of colors is what shapes the bow. In rainbows, that angle is often described as a characteristic slant, an angle that decides where each color will appear. You don't need the exact measure to feel the calmness of the pattern. Imagine it as a steady tilt, a private rule that every droplet follows when it makes color. Dew on grass becomes 1,000 miniature prisms. When the morning sun rises, those dewdrops catch light and paint the meadow with pale, scattered rainbows. Each blade that glitters holds its own tiny world of color. Walk slowly through the grass, and the world shivers into shimmering, jewel-like flashes. If you ever see a spiderweb bright with color, know that each bead of water acts like a lens, collecting and refracting the same visible spectrum that paints the big sky bow. Pearls of water on a car hood after rain will do the same, tiny orbs of ordered color. Diamonds and glass play with light similarly, but with a twist. A diamond's sparkle has more to do with how many times light bounces inside a cut than with color alone. Still, when light leaves that jewel, it can separate into little flashes, fire that catch your eye in reds and blues. This is dispersion made tiny and exquisite, the same physics that draws colors from a raindrop, folded and returned on a smaller, sharper scale. There is a softness to how nature arranges color. It is a conversation between light's wavelength and the shape of whatever meets it. Water curves, crystals facet, tiny droplets clump, and each form asks light to answer in a particular palette. Now let your attention widen from the raindrop to the whole sky. Why is most of that vast dome a cool, tender blue? The explanation is simple and gentle. Air is filled with tiny molecules that scatter sunlight. Blue light has shorter waves, and shorter waves are nudged around more easily by the microscopic bits of gas between us. So instead of heading straight to your eyes, a lot of blue light bounces around and fills the sky. That's why when you look away from the sun, the world looks like a soft wash of sapphire. At sunrise and sunset, the story changes in a way that feels almost like a breathing exercise. The sun leans low, its light travels through more atmosphere, and the shorter blue waves scatter away before they can arrive. What remains are the reds and oranges, longer waves that travel straight through the thicker air. The result is the sky on fire, an old phrase that is less violent than poetic. The low sun stretches its colors into long, warm ribbons that sweep across clouds and reflect on windows and puddles, folding the ordinary world into a painting. There are nights when the moon, too, makes a delicate bow, moonbows. They are faint and often pale because moonlight is much softer than sunlight.
Think of moonlight as sunlight reflected from the moon's surface. It's dimmer and cooler, but if a rain shower and a bright moon line up, the same geometry that makes rainbows by day will produce a nighttime arc. Where a daytime bow is vivid and easy to peer into, a moonbow feels like a quiet memory of color, pale, almost whispering its shades. The atmosphere gives us other fine spectacles when crystals replace droplets. High, thin clouds of ice form hexagonal plates and columns that act like tiny, perfectly cut prisms. When sunlight or moonlight glances off these ice crystals, they sometimes create halos, glowing circles or arcs enclosing the sun or moon. One common type is a ring at a certain distance from the bright source, a soft circle that seems to hold the sky in a cool glass frame. Sundogs or parhelia are bright spots that appear on either side of the sun, like companions made of light. They catch you with their regular geometry. Light refracted through similarly oriented ice crystals appears at predictable positions, and because many crystals line up, the result can be startlingly precise and serenely gentle all at once. Elsewhere in the air, very small droplets or uniform particles can cause iridescence, those soft pastels that run along the edges of clouds or the thin veil of a wave. Iridescent clouds wear colors like mother of pearl, dissolving into gentle pinks and greens where droplets diffract light. This is diffraction, light bending around small structures and interfering with itself, creating color bands that are softer than a rainbow's edges and move like silk in a breeze. Look down and you'll see similar textures in unexpected places. The sheen on a beetle's wing isn't caused by pigments alone, but by tiny layered structures that scatter light in particular directions, producing brilliant blues and greens from the same physical trickery that makes soap bubbles shimmer. A soap film across a hoop glows with floating color because the film's thickness changes, letting certain wavelengths reinforce each other and other wavelengths cancel out. These are intimate, tactile ways that light and small-scale structure dance together to form color. And sometimes light comes to us in columns. Snow on a cold morning can reflect sunlight upward in beams that extend into the air. Ice crystals on calm mornings can produce sun pillars, vertical shafts of light that appear to stand on ice-crisp ground. They are like quiet lighthouses, made entirely of reflection and meant not to warn but to charm. All of these near-Earth spectacles, rainbows, sundogs, halos, iridescent clouds, dew prisms, share the same fundamental facts about light. They are all rearrangements of sunlight by shape and structure. Water bends and reflects, ice refracts and orients, small particles scatter, layered surfaces interfere. In each case, color is not an added-on property, but the way light itself has been sorted and presented.
Let your imagination travel through that sorting. Take a single photon from the sun and follow it as it meets a droplet, curves, splits, and returns to your eye, carrying a choice of color, a small piece of sky tailored just for you. This is also why rainbows feel so intimate. They are not painted on the sky as if the atmosphere had a paintbrush. They are a conversation between you and the light, a pattern that needs the viewer in a particular place to exist. Every bow is, in a way, made for the person who sees it. That personal quality invites a kind of calm respect. The world is arranging color specifically in response to where you stand. There are still soft variations to consider. When droplets are very uniform and tiny, rainbows can blur and wash into misty bands. When raindrops differ in size, the colors can shift and broaden, yielding subtler transitions. In some rare moments, the arc will be joined by reflected light from the surface beneath you, double rainbows, made of a real rainbow and its reflection in a large, still lake. Imagine standing on a shore at dusk, the sun low and sticky with color, a bow stretching across the sky, and its companion lying faintly on the mirrored water. Two arcs for two worlds, one above and one below, both speaking the same gentle language. Now let us move a little further from hairline droplets and glass prisms toward a different kind of instrument that reveals even more of light's nature, the spectroscope. A simple prism yields a peaceful strip of color. A tool called a spectrograph in a telescope unpacks light into its hidden phrases. When sunlight or starlight is spread out this way, it shows dark lines and bright lines, tiny fingerprints that tell us what atoms and molecules are present. These lines are quiet clues. Sodium will whisper in one place, hydrogen in another, and with them we can learn what cosmic clouds are made of without touching a single grain. The colors we see, those reds and blues and greens, are the visible part of a broader family. Light extends far beyond what your eyes can perceive, to longer waves like radio and infrared, and to shorter ones like ultraviolet and X-rays. But the rules that shape a rainbow's curve are the same rules that let astronomers read the story of stars. Think of the sun now, that steady, luminous neighbor. When we look closely at sunlight through a fine glass, we see not just color but context. Fraunhofer lines, as they are sometimes called, are thin, dark marks made when atoms in the sun's atmosphere absorb specific wavelengths. Though we won't linger on every line, it's soothing to imagine that this light is a record, a map of what the sun is and what it contains. The sun's golden tone is a balance of many wavelengths. The warmth you feel is made of countless photons, each carrying a little packet of color. Extend that thought to the stars. Stars wear color like a temperature scale. The hottest stars glow with blue-white light, sharper and more intense, while cooler stars glow redder and softer. That color tells us, in a simple way, how fiercely a star's surface burns. When you look up at a blue-white star, you are seeing intense, high-energy light. When you rest your gaze on a red-orange star, you are seeing a gentler ember. It is as if the cosmos sketches its own temperature map, its palette a direct reflection of physics. As starlight travels toward us, it sometimes passes through interstellar dust. That dust does not blot out light so much as repaint it, favoring redder colors by scattering the bluer ones away, what astronomers call reddening. It is similar to the way the low sun's light turns the sky to orange at dusk. A long path through dust picks out the red notes and sings them forward. This process is soft and gradual, more like the fading of a watercolor than the smearing of paint. There are moments when particles from the sun itself meet the Earth's magnetic fields and stream towards the poles. They strike atoms in the upper atmosphere and excite them, and when those atoms calm down, they release photons of particular colors, greens and pinks that ripple across the sky. These are auroras, living curtains of light. They are, in truth, ordered collisions, yet to the eye they feel like a quiet performance, curtains folding and unfolding on a vast, dark stage. The colors there are dependent on what atoms are involved and how high the interactions take place. Oxygen gives a green that fills horizon to horizon. Nitrogen can produce deeper reds and purples, rarer and more elusive. Auroras are a reminder that light can be an action, a release, a subtle music made visible when particles settle into lower energy. From the small and immediate to the vast and patient, the same physics travels: refraction, scattering, interference, emission. That continuity is what makes it restful to think about light. The same tendencies that shape a pearl-colored cloud play out in the glow of a distant nebula. A rainbow and a spectrum line are relatives in a family of processes that sort, color, and carry information across scales and ages. As your breath eases, let one more close image settle: the prism of glass and a small circle of light on a wall. Inside that circle, you can see a gentle gradation from red to violet. But look more carefully and you might notice tiny gaps, dark scratches, soft notches. Those marks are records of what the light has passed through or over. Light, in a practical sense, carries information. Metaphorically, we can think of it as a messenger of histories. When a photon from a blue star reaches you, it has weathered dust lanes, magnetic fields, and the slow drift of space itself. It is a calm courier across space and time. When you follow that thread farther, however, a different sort of bending can take place. Gravity, as laid out by Einstein, can curve the path of light.
Imagine a massive galaxy sitting between you and a more distant bright object. The mass of the nearer galaxy doesn't deflect light by tugging at photons as if they were pulled like a rope. Instead, it warps the space the light travels through. The effect can be as elegant as the glass lens in a jewelry store. Light is bent into arcs, smudged into rings, or multiplied into several ghostly images of the same object. These gravitational lenses are often subtle, like looking through wavy glass. Sometimes they produce dramatic arcs, or even an almost perfect ring around a mass, Einstein rings, where the geometry aligns with rare, serene precision. You might picture these rings as cosmic rainbows in a way. They are formed not by water, but by gravity shaping light's path. The similarity is in the pattern. An intervening structure sorts light into specific, ordered arcs. In both cases, geometry and the innate behavior of light work together to create shapes that feel almost designed for our eyes. There are many more quiet corners to touch. The cosmic microwave background that hums as the oldest light, redshift that gently stretches color across expanding space. But those belong to the broader field we will arrive at soon. For a moment, remain with the near-Earth gallery. A drop, a prism, a halo, dew that glitters like a scattering of tiny bows, and the slow blue dome of a sky that so often calms the mind. Each of these scenes is a small lesson in how light behaves, offered in a tone both precise and tender. Before we cross further into the night and the distant glow of stars and galaxies, let your attention rest on this thought. Light makes knowledge tactile. It exposes composition, temperature, motion. It carries tiny signatures of the places it has been, as music carries the memory of the room where it was played. In the next part of our quiet tour, we will follow light beyond what your eyes can see. We will listen to radio whispers and infrared warmth. We will learn how the oldest light from the early universe washes the cosmos in a faint hush, and we will let those broader, older lights fold into the same gentle narrative that began in a single raindrop. For now, bring your awareness back to the drop on the leaf. Watch it hold the spectrum like a small world. Imagine, gently, that each color there is a tiny messenger, and that same messenger can travel further and wider, carrying those hues into realms you cannot yet see. Breathe in as you picture the red, orange, yellow. Breathe out as the blues and violets soften. There is a continuity to this tuning, the same rules, the same quiet mathematics, making beauty out of light and position. When you are ready, we will begin to follow that photon out of the atmosphere and across the darker lanes of space, where light becomes an archive and a map. For now, keep the image of the raindrop and the prism close. Let it be a small, luminous island. The deeper journey waits, patient and wide, and when you are ready, the colors will unfold again into a larger, older sky. When you lift that image of the raindrop again, imagine now that the tiny beam that spilled into color slides outward, past the garden, through the roof, and escapes into the night. Follow it with only your attention, slowly, as if your eyes are hands gently trailing a thread. That same family of rules, bending, scattering, splitting, travels with light beyond our roofline and out into the open, where stars make their own color. Lanes of dust and wisps of gas stretch and pool, and these materials change the light's dress. Dust prefers the blue, nudging those shorter waves aside and letting longer, redder light continue. Astronomers call this reddening, and for the eye it works like a watercolor wash sliding across a page. The deeper the dust, the more the blue fades and the red becomes the apparent color. It is gentle and gradual, not violent, more like someone turning down the cool tones of a painting until only warmth remains. When charged particles from the sun spiral along Earth's magnetic field and strike atoms in the upper atmosphere, those atoms bloom into color and then calm. The aurora is this bloom made visible on a grand scale. The greens and pinks that glide above polar horizons come from oxygen and nitrogen trading tiny amounts of energy. Imagine a curtain pulled across a vast theater that shifts hue depending on which performer has just left the stage.
Sometimes the curtain is a slow, luminous wash, sometimes it ripples with rapid, delicate folds. Here again, light is a messenger. It reveals motion and energy in a language of color that we, blessedly, can enjoy without understanding every technical detail. Beyond auroras and sunsets, light runs across a grander scale of variety that we can only glimpse through instruments. The electromagnetic spectrum is a gentle ladder of kinds of light. At one end are long, slow waves we call radio. They are like the bass notes of color, expansive and roomy. Move up a rung and you find microwaves, the glow of the ancient universe we will visit soon. Higher still is infrared, warmth you could feel on your skin if you were close enough. Then comes the narrow band of visible light, the silk of color the human eye perceives. Above that lie ultraviolet, X-rays, and gamma rays, shorter, more energetic waves that require specialized detectors to witness. The important calming fact is this: all of these are the same phenomenon, differing only in wavelength and energy. They are relatives, not strangers. What a radio telescope hears and what your eye sees are both light, sung in different voices. One of the most peaceful members of that ladder is the cosmic microwave background, often called the oldest light. It is light that began when the universe was very young, and since then its wavelengths have been stretched by the expansion of space itself. Now it reaches us as a hush of microwaves, bathing all directions in an almost uniform glow. When astronomers map it, they see tiny variations, small ripples in temperature across the sky that point to ancient processes at the universe's dawn. Picture that glow as a faint, warm afterglow of the cosmos' first impatient breaths. We call this a relic because it carries information about how the universe began to take shape. When you imagine it, think not of a harsh light, but of a distant, softening warmth that has cooled and stretched on its long journey.
The stretching of wavelengths is a central idea you will meet as we travel outward, the phenomenon known as redshift. It means that light's apparent color shifts toward the red end of the spectrum as the space it traverses expands. If a galaxy is moving away from us, if it is being carried outward by cosmic expansion, its light arrives with its colors shifted to longer, redder wavelengths. Redshift is not a loss of energy in a moral sense, but a change in scale, a stretching of the wave itself. It is the universe quietly lengthening the notes of its music. Through redshift, we can tell how far and how fast objects recede, and we can watch the story of cosmic expansion unfold in color. As light travels, mass can bend it in a way that is surprisingly like glass. Massive objects, according to Einstein's view, warp the very fabric of the space through which light moves. The result can be arcs, stretched images, and sometimes near-perfect rings when geometry aligns with rare elegance. Astronomers photograph these gravitational lenses as visions of ghostly repetition, a single galaxy appearing in duplicate, triplicate, or as a soft arc wrapped around an unseen mass. Imagine looking through a glass paperweight and seeing a tiny, repeated pattern of a scene beyond. Gravitational lensing is a cosmic-scale paperweight that occasionally rearranges distant light into something new and oddly symmetrical. These lenses let us see objects that might otherwise be too faint or distant, and they show us gently how gravity and light cooperate to shape our view. There are other quiet ways that light keeps memory. When a star explodes, it can flood the surrounding space with a bright pulse. Some of that pulse can reflect from distant dust clouds and arrive at our telescopes years later, like echoes of a clap in a canyon. These light echoes present as expanding rings or arcs of light around the area of explosion, a slow-motion replay of a brief, intense event. When you picture a day's thunder leaving a shadow that lingers in slow motion, you begin to get the softness of a cosmic light echo, bright, then reflected and spread out, arriving as a delayed, glowing whisper across space. Nebulae, those painted clouds of gas and dust, are laboratories of light and color on a grand scale. Ultraviolet light from hot, young stars excites the surrounding gas, which then re-emits photons at characteristic colors. Think of hydrogen, abundant and patient, taking in higher energy light and exhaling visible reds that we see glowing in the heart of many nebulae. Oxygen can lend a cool green-blue glow to other regions. These hues are not mere decoration, they are signs of physical processes, of ionized gas writing its state and light. When you look at a nebula's soft edges, imagine the slow exchange of energy, light arriving, atoms dancing, light departing, with each photon a small announcement of what just happened. Supernova remnants carry a different kind of beauty.
After a star's explosive death, its outer layers sweep outward, crashing into surrounding material and lighting it up. The
The result is a shell of glowing gas and high-energy particles tracing the shape of an old event. These remnants can be colorful to instruments tuned to X-rays and radio waves, and to our eyes they can appear as filigree shells of emission. The story they tell is one of transformation, stellar interiors flung outward, seeding the nearby space with heavier elements that will one day become the raw material for new stars, planets, and quietly, you. That fact is one of the most tender things to think about. The atoms you carry were once inside stars. Elements heavier than helium, the carbon in your cells, the calcium in your bones, the iron in your blood, formed in the bellies of stars and in the violent fire of supernovae. In a literal and simple sense, you are composed of material that once burned and cooled within stellar furnaces. Saying we are made of stardust is not poetic exaggeration. It is a factual shorthand for a long chain of transformations. You can rest in that connectedness. It is an intimate kind of belonging. Your chemistry speaks of distant, ancient craftsmanship. Photons and particles flow through you continually. Every moment, countless photons from the sun, the sky, and the lamps around you pass through your skin and the spaces between your atoms. Most do not stop. They simply course through, bearing impressions of where they have been. Some carry the fingerprint of a tree leaf. Others have traveled from distant stars. Each one is small and unassuming, but together they compose the light that informs your world. To think that these tiny messengers reach into your being and return information to your eyes is a gentle comfort. You are not separated from the universe, but threaded into it by these unending streams of light. There are places where light behaves in extreme, though not alarming ways. Near a black hole, the path of light bends dramatically, and time, as measured by a distant observer, appears to stretch. Say this softly. In regions of extreme gravity, the rhythm of light and time differs from what we would feel on Earth. This is a distant, abstract effect. It is not something that touches the safety of your night. It is, however, a humbling reminder that the universe contains conditions that tune light's behavior into forms we rarely imagine in day-to-day life. We can also sense the scale of light's history when we consider the oldest photons that reach us. Some of the light we see from very distant galaxies left its place billions of years ago. When that light began its voyage, the universe looked different in density and temperature. By the time those photons arrive at our telescopes, they have passed through cosmic filaments and voids, through gravitational fields and expanding space, and they carry with them the layered story of what they encountered.
Looking at a distant galaxy is, in a way, looking back in time. Its color and its redshift tell us about both motion and age, and in the slow, careful reading of these properties, astronomers reconstruct the histories of far-off worlds. The instruments that translate these distant hues into usable data are mappings of light into soundless, readable forms. Radio telescopes catch the long, patient waves and reveal colossal structures. Infrared cameras show warmth that suggests hidden stars forming inside dusty nurseries. X-ray observatories reveal the hot, violent regions around compact objects. Each device is like a different kind of eye, specialized and steady. They do not change the fundamental nature of light. They extend our sense of it. Consider that each instrument broadens the family of light you can sense, enfolding more of the universe into your understanding with gentle reliability. Now, let your mind slow and hold an image that links the nearby and the distant. Picture the raindrop once more, hanging from the leaf, refracting a sunbeam into a tiny bow. Fold that image outward. Imagine cousins of that photon, born in the furnace of an ancient star, traveling across expanding space, stretched into microwaves, and arriving as part of the faint cosmic glow that wraps the universe. The physics that bends and colors the beam on your leaf, the way wavelengths separate and scatter, are the same principles, expressed on a larger stage. In one case, water shapes a local spectacle. In another, gravity and expansion shape a cosmic tapestry. They are relatives by law, not identity. The raindrop's photon and the cosmic background's microwave are not the same single particle, yet they belong to the same family of light and the same set of rules. Let that kinship rest in you like a soft, connecting thread. There is a special kind of calm in realizing that the same phenomena operating in a dewdrop can, when scaled, tell us about the history of the cosmos. A prism and a galaxy cluster both organize light. A soap film and a nebula both make interference and emission visible. The universe saves its vocabulary across scales: refraction, scattering, emission, absorption,
bending. To hold this in your imagination is to sense a coherence that is both scientific and soothing. It means that the small lessons you learn from a rainbow are not trivial. They are keys to understanding the larger story. Imagine yourself as a patient instrument, a calm observer. Breathe in and picture the chain. Drop to prism, prism to telescope, telescope to a map of the oldest light. Each inhalation draws you in. Each exhalation releases the image. Let the colors slow with your breathing. As you inhale, imagine the reds arriving first, long, warm waves stretching like a ribbon. As you exhale, let the blues fold back, shorter, cooler notes that bounce easily. There is no need to count. Let the patterns simply accompany your breath, a soft metronome of color and calm.
Gently, think of gravity's lenses again, and visualize them not as distortions, but as windows that sometimes rearrange light into artful curves. Picture a distant galaxy multiplied into twin images around a nearer mass, each copy a faint echo of the other. In these echoes we find meaning. The universe gives us multiple views of a single truth. That multiplicity is not confusion, it is a blessing of geometry. Like a chorus repeating a melody in harmony, the repeated images tell us more than a single view could. If you let this settle, you may begin to feel a widening sense of belonging. The atoms inside you were once forged in distant stellar hearts. The photons bathing your room share kinship with microwaves that whisper of the universe's infancy. The colors you love in a sunrise obey the same physics that paint nebulae in telescopes. There is a continuity here that is both factual and consoling. You are a node in a web of light, and in that web, the quiet rules provide a predictable, steady order. Now ease into a moment of calm reverie. Close your eyes if you like, and imagine the scene merging. A single raindrop refracts the sun into a miniature bow. That bow is a small echo of the broad sweep of the spectrum printed across the cosmos. The moon may be rising with a pale brush of silver, beneath which distant auroras hang like quiet curtains. Overhead, stars of different colors hang in a silent choir, their light aged and patient. Far beyond, the cosmic microwave background hums as an ancient lullaby, a soft radio of the universe's first warm moments. Let each element blend seamlessly with the others, micro and macro, the personal and the universal, held together by the humble, tireless behavior of light. As you lie or sit there, feel the rhythm of your breath match the slow procession of these images. Breathe in as you picture a photon born in a star's core beginning its long journey. Breathe out as it glides through dust lanes and around the curves of gravity. There is time in these images, billions of years in some, minutes in others, but even the longest timelines feel gentle when you watch them as color and flow rather than as numbers. You are invited to be small and held at once, a human mind tracing the path of light that bridges immense distances. A final peaceful fact: when you let your attention go, light will continue its work, sorting, carrying, reflecting, without hurry. The sun will still spill photons, rain will still make arcs, and the ancient glow of the universe will keep its slow, patient presence. There is a kind of quiet reliability in that continuity. The physics that makes a rainbow tomorrow will be the same physics that made the first whisper of the universe. Thinking of it this way, you can rest in both wonder and steadiness. If tonight's quiet wandering among colors and scales felt like company, consider subscribing for more gentle explorations of the universe. For now, let your breathing soften. Imagine the reds melting into oranges, oranges into yellows, and the yellows into a cool, deep blue that fades into velvet. Let the image of the raindrop and the distant hum of cosmic light fold together until all you notice is a soft, luminous darkness, like the slow closing of an eye. Good night.